Hello everyone, we are C63 Studio, and the project we built for innovation project this year is a project management tool. In this video, we will show briefly the key aspects that were done during the project. So this is the main dashboard of the application, when you can go and see all the available tasks in the project. You can add new tasks here, and you can view the details for each task. Here you can see you can add the new task based on the model we provide. You can add task name, description, and you can choose which people are going to be involved in the task. And here is the detail in the task. So you can see the title, the task description. People can comment here. People can add more here to get involved in the task. This one is an alternate view for the dashboard. And this one is the fully visual of the application when we finish. This one is the login screen. And this one is the project page based on the theme. So we have different themes, and each team has different project.
There are many options for building a JavaScript front-end application nowadays, but we are now using React at the beginning, because React is a very lightweight library, and it's also increasing the reusability and also the customization of the component. For state control and flow control, we're using Redux, and at the beginning we start with getting React border place that have a React and a Redux built-in, and coming with also a lot of webpack configuration about hard reloading and file and build file build. For building small component, we use React Bootstrap. It's actually Bootstrap, and it's building for React. We start by creating a mockup with a design. Later then we integrate with backend. For action handling, we use Reductang, so you can inspect a lot of action at the same time. And for that output data, we normalize it with normalized CS, so the data will not be nested. And for stay comparing, we use immutable JS, so it will keep the state immutable in the reducers of Redux. About CSS, we use SAS syntax and also the BEM structure, so we can keep the CSS structures and without duplicating each other. For time formatting, we use Moments.js, and for text translating, we use React International. We also use Lodash as with some basic function.
The first 3 months we try to develop module backend using microservice style. So I try to use the Netflix open source software, and also using Spring Boot to take advantage of the history, Eureka, Ribbon. And then we try to use Docker to container microservice, and using Kubernetes to do the orchestration for our application. However, there is some difficulty that we experience during the development time, like the Kubernetes and Docker is good for development, but it's really hard in staging server and in production server. The Docker is not good enough for some I/O tasks and like database and if we use RAS service provided by Amazon Web Service, then it's hard to connect it to the already deployed Kubernetes cluster because of the closed VPN and so on. And also for the small scale the current application, it really has two different built-in microservice, and then so we decide to rebuild the application in monolith style and develop another infrastructure using that support continuous delivery, and then we use a source stack and
the reason why we chose to use continuous delivery practice is to actually to automate everything and code our infrastructure as code, because we have limited in human resources. So without the help of automation, we actually cannot deliver the project on time. So for a CD pipeline, it needs some kind of a core technology infrastructure using like configuration management that we use is a source stack, so code control GitHub, continuous integration where running user unit that is Circle CI, and then for the delivery and visualize workflow and software model link we use GoCD, and then finally for the monitoring the server we run it with Telegraph as a log parser, and then put the output to the CloudWatch metric, and then fed that metric from the Amazon CloudWatch server into our visualization software. Yes, so I will continue talking about our infrastructure, the VPC environment, virtual private cloud in Amazon. We have a VPC with two subnets, public and private. In the public subnet, we have one instance functioning at a VPN server and also at a NAT or network address translation server. In the private subnet, we have GoCD, the continuous delivery visualization software running, and also the source stack configuration management system master agent running inside here, which will then control all other server, the VPN server, backend, front-end, start, and Postgre. We have one backend server, one front-end server. The start server is where we monitoring our services, and we run our database in Postgre SQL RDS instance provided by Amazon, so it have built-in high availability and monitoring and everything. To be able to access into this kind of services like GoCD, start and access our infrastructure, people need to have a VPN connection here running to be able to get access inside this private subnet. Yes, and I can from the development point of view, whenever a developer push code chain to a GitHub repository, the code chain will actually trigger the Circle CI at a integration test and also unit test system. It will trigger here. For example, you can see this is a build pipeline, and it will run all the unit tests. After that, if the unit test pass, we will auto-merge to a release branch, and it will go to our GoCD pipeline here for the front-end system. Inside this, we have 3 different pipelines. For the front-end, it will actually trigger the integration test with the back-end, and then deploy to the server, staging server. So
just the code chain from the Git repo will actually go everything automated to the running service. And we show Go CD as a CD pipeline visualization tool software because it open source and very beautiful. And you, for example, here let's go to the back and pipeline. Here we can see the output log of the building, everything here. And then for the monitoring system, we inside each server we have a telegraph as a log parser. It will output to CloudWatch. Here you can see in the CloudWatch matrix from console in the Amazon, it outputs the system domain, and then all the matrix like CPU usage, nice, idle, and everything. So we can put the data here. We can visualize it in Amazon also, but we have a centralized server for visualizing them running in our start server here. As you can see, we can see the CPU database network output input, and also disk usage, so we can maintain our server, know how performance of the system running.